So today's topic we are going to discuss about post estimation. Okay. So some of the things that we are going to cover is just an introduction about what is post estimation, where it is getting utilized, some of the approaches within post estimation, what are the types, and also we're going to look at some of the methods that are being used currently, but there are in fact more, right? And also we are going to directly get into the code demo in the majority of the portion. Okay. So before I sort of begin, let me just share some links in the chat. Okay, so I have pasted a link in the chat. So this gives you access to a Google Drive where you will get a zip file, openpost.zip file. It's about like 370 MB. So request all to go to this link and download it in your system. And also, once you have downloaded that, please log into our CellStrat Hub. So you can, if you already have an account, you can directly sign in. If not, you can sign it up. It hardly takes a minute. Okay, so two things. One is download the zip file in your folder and then log into your CellStrat Hub. Okay, so these are the two key things. While you do that, I'm going to cover the presentation for a couple of moments. Okay. So once you're ready, just put a thumbs up in the chat so that we can continue with the demo directly. And meanwhile, in between, I'm going to toggle between the concepts and the demo. Okay. All right. So what is post estimation, right? So it's one of the computer vision tasks. So the main thing what post estimation does is whether it be an object or a human or anything, right? So it basically tracks the number of key points. So like just look at the image on the right. What we see is so these are a couple of objects that are there, right? So it kind of tracks the edges of each and every object. So it's like a bounding box has been drawn on top of the objects, and then it helps you to detect the key points. So look at this edge, right? So this is a key point here. So same way for even for humans, what it does is there are n number of key points within a human being. So it kind of detects your head, your elbow, shoulder, and all those things, and it will give you a clear-cut key points within an image. Okay, so that is primarily on what is a pose estimation. Now let's look at where or how we use this pose estimation in some applications, right? So the first and the foremost would be your activity recognition. So you would have seen the surveillance engines or the web cameras and uh, surveillance, especially surveillance, right? In traffic or airport and so on and so forth, right? So uh, these help us to kind of detect certain things, right? So it could be, let's say, if a person is met with an accident or not, if they has fallen or not, even the sign languages, if they have so these are basically to enhance your security and surveillance. Okay, so that is what activity recognition is. That is one of the areas. The second one would be your motion capture or augmented reality, right? So many of the movies nowadays uses CGI, right? So that's more predominantly used, right? So what they basically do is there would be somebody who would be acting behind the screen, and then using graphics they kind of populate all the other stuffs, right? So for animated movies, like some the actors or characters, right? So they kind of enact it and then apply CGI over it. So as I told before over here, so they capture all the key points and then convert it into CGI. Okay, so that is where, and Apple's Animoji, right? So many of you who use Apple phones, you would have seen the recent update last year, right? The Animoji. So that is also one of the applications. And the next one would be your training robots, right? So training robots is also one of the things, and the last one would be your gaming, typically, right? So nowadays you have virtual reality, right? So in virtual reality, basically it tries to track the motion of human objects, and then it kind of gives you the same character or structure or key points in your virtual world. A classic example would be your virtual gaming or even metaverse for that matter, right? Which is something Facebook is, advertising big time. So those are some of the applications of post estimation. Now, have you all downloaded and logged into your CellStrat Hub? Are you able to download this and log into your CellStrat Hub? Just give a thumbs up in the chat so that we are aware that all of you have done that. So I'll probably take another 1 or 2 slides and then we'll move into that. So there are two key approaches within post estimation. Okay, one would be the bottom up approach and the second one would be the top down approach. So what does bottom up and top down mean, right? So just look at the example on the right side, right? So you have two people as inside an image. Now, in your bottom up approach, okay, what it does is it kinds of gives you like it detects the parts. So each and every part will be detected, and then finally it will give you a key points. So this is what we have seen before, right? So it kind of gives you a skeletal structure to your human body, right? So basically, in simpler terms, the algorithm predicts all the parts and joints present in the image, and then it uses a formulation of graph to detect your human. But in the top down approach, it's just the reverse. It creates a bounding box first, and then what it does is individually on each bounding box it kind of creates the dots. So this is your box. Okay, within each box you will try to it will try to align the key points. So this is your head, shoulder, the elbow, the hand, so each and every point. So more or less the final output or outcome would remain more or less similar, but the only approach it takes is first it identifies the entire object or a human, and then it tries to align the skeletal system, right? But in your next approach it finds out the key points, like for example there will be a dot, or like it's more or less like a heat map. Okay, so when you do an object detection it tries to identify the heat areas where the object or the image is available, right? So it kinds of gives you a dot and then it tries to form the skeletal system. Okay, so this is just two approaches. And then the types, there are three different types in a typical human pose estimation. Okay, so what we saw, what I explained before is the typical, the skeletal structure of a human body. So that's called as a skeletal based model, or we call it as a kinematic model. Okay, so it's straightforward, right? The second one would be your contour based model or planar model. Okay, and this is primarily used in terms of 2D pose images. And what it does is it kind of gives you a boundary box, right? So that's what we have seen here. Okay, and the third one would be your volumetric. Now volumetric typically it gives you like a geometric shape, meshes and shapes, right? So it kind of identifies the edges of your human body, and it will also give like a color coding, sort of like a heat map sort of a thing, right? So let's say for example if you want to detect only a particular maybe a head or an elbow, right? So you can give a specific code, what do you call it, the color code. Okay, and basically this is used for 3D human models. Okay, so these are like a couple of types of images. And then we'll go to the methods. But before we move on to the methods, I will first, what I will do is I'll just, so this is the link that I've been shared before. So you will get a openpost.zip. Okay. And once that is done, please go to the next link where you will have the CellStrat Hub. So once you log in, this is the landing page or a home page that you will get. So there, all you need to do is go ahead and start your workshop. Workspace. So it will take a couple of moments to start the workspace. So before that, team on the call, are you all ready with downloading the image, I mean the zip file and logging in? And please feel free to ask any questions. I'll just take a pause for a minute or two for any questions, and then I'll move on once it logs in. Okay. Any questions, team? All right. If not, let me go back to some of the methods and I'll just come back. Okay. So, uh, so I've just listed down a couple of key methods that are being used. Okay. So the first and the most popular one would be your open post method. Okay. So your open post method. So this is a multi-person human pose estimation model, and this uses real time, right? So it kind of has an API. What it does is you can, so if you have webcams or cameras or some surveillance systems, etc., right? So you can directly use this API. It gives you that sort of a flexibility to directly integrate it to your, webcams and all, and it can do a real time, detection of your poses. And there is also a lightweight version available. So what this does is, like, you will have a couple of edge devices, right? So it does an on-device processing of in real time for those edge devices. So this is one of the most popularly used methods, and this is the we are going to see today's demo, or rather the code output, right? So the code demo we are going to see on OpenPost. Now, the overall architecture for any of the post estimation methods typically follows CNN. Okay, it is just that based on the research and the development that has occurred by multiple researchers, they have just used CNN, and on top of that they have either created some additional layers, or tried to put some backward propagation or forward propagation, and then add some additional biases. So these are some of the modifications that they have done in the existing CNN to arrive at this. So there are a lot of research papers that are available on each of these methods, but the most popular one is OpenPost, and this is what today we are going to see. The second one is high resolution net. This is also similar to your OpenPost, but here what basically it does is, as the name indicates, right? So it basically picks up all your low resolution images and converts it into a high resolution image as much as possible, and then it will estimate the posture. Typically in your televised sports, right? So the sports that you see, so those things, like, because of the movements and all, your pixel size kind of gets reduced, and there is a lot of movement, right? So your resolution kind of gets reduced. So what it does is, it will try to retain that higher resolution as much as possible, and then try to give you the key points. The next would be your deep cut. Deep cut is a bottom up approach, and this is again used in, again, sports only, but this is more on real time sports, right? So if, let's say, for example, if you want to kind of understand, so if you're keeping an image in, let's say, a football match or a tennis match, right? You want to capture the real time movements of a particular person on the court, right? So you can leverage this. Then we have something called as an alpha pose. So alpha pose, again, it is used for single as well as multi-pose poses. It will again detect bounding boxes, and from bounding boxes it will detect your key points for human pose estimation. And the last three things, again, these are some of the, so these are some of the things which I'm talking about, but there are more, right? So deep pose, postnet, dense pose, these are all you can utilize it for single or multi-pose estimation. Some of the things are like, some of postnet is like used for browsers or mobile devices. Dense pose specifically, it is used for 3D. So like that, each method has its own application, or rather its own rules, right? So you need to, so based on the use cases that you select, you need to choose the method which is apt for your to model your pose. And the main thing here is, since everything follows CNN, it is not limited to these methods. There are multiple methods. Even Facebook basically uses a method called as deep motion, which is what is getting utilized in metaverse, right? So some of the concepts are same here, but predominantly there are additional researches going on, and you will get more models in the market. Okay, so let me just go back to, okay, so my workspace has been started. So team, I just want a quick confirmation on the chat if everyone are on this page, you have started the workspace. So once you start the workspace, you will get something called Launch Jupyter Lab. So just click on it and it would kind of go inside the Jupyter Lab session of your CellStrat Hub. So meanwhile it loads, I just take a pause here for any questions. You're able to download and do all this.
Yeah. So this notice for Utsav. Utsav, for me to reset your quota to 0 hours, kindly stop the workspace. Then I can confirm it, and then I can reset your quota to 0 hours. But you still have 5 hours left. I can see that.
Okay, all right, and okay. So coming to this one, right? So you don't need to, get any packs over here. Whatever the zip file that I have shared, it itself contains code, right? So what you need to do is once you download the zip file, so this openpost.zip. So once you download it, all you need to do is just drag and drop it here, right? So for example, let me also do that. Okay, so basically I have just downloaded this openpost.zip. So what I'm going to do is just drag it and drop it over here on the left hand side, right? So it's going to ask me that, okay, large size forwarding, just go ahead and click on upload. So it will take a minute or two for the file to upload based on the connection speed, right? So hope everyone are able to drag and drop the zip file onto this space over here. Any issues that anyone faces? Okay, all right. So it's sort of loading. So you see that, you can see the progress bar over here. It kind of gets loaded. Once loaded, so whomsoever has already copied the zip file over here, probably once it is copied, all you need to do is just click on this, right click, and there is an option called as extract archive. Okay, so just for the interest of everyone, so once you log into this page, you start the workspace, and then on the right hand side you will have something called Launch Jupyter Lab. Once you click on it, it will go to this page. Here, whatever zip file that I have given you earlier from your local system, just drag and drop it to the left hand side space over here. You see that it's still getting uploaded, and on the left hand side you can see that a zip file is kind of getting created, right? Once this bar is completed, you right click, extract archive. Okay, once you extract archive, there will be a folder like this created called as open posts. So I'll just give one minute.
Many folks have joined
Meanwhile,
now.
yeah.
Can you please give instructions what we have to do again? And many are still joining.
Sure.
Many are still joining. So kindly just wait for 10 seconds and then,
Sure.
give instructions from beginning what folks have to do.
Sure.
Now you can maybe specify what folks have to do for workshop.
Okay, all right. So team, like on the right hand side messages, you would see a link to Google Drive. Please click on that. Once you click on that, you will be able to get a file called as openpost.zip. Okay, so all you need to do is just right click and download that file in your local system. So that's the first step. And the second step is go to the next link, that is cellstrathub.com. Okay, there all you need to do is log in there'll be a login option on the top. So please log in. Once you log in, you will be able to get this landing page. There on the left hand side, you will have something called as a start workspace. So click on that, wait for a few seconds. You will be able to see launch Jupyter lab icon over here, which will be able to click on that, and then you will get this page, which is your Jupyter lab page. Okay, that's the second step. Now, once you have downloaded the .zip file, so all you need to do is go to your local folder. So let's say I have downloaded the openpost.zip file over here. I just drag and drop it on the left hand side pane. So here, since I have already dragged and dropped, you can see that openpost.zip is copied here. Now just right click. There's an option called extract archive. So once you click on that, the zip file will be extracted in this space and you will get a folder by the name OpenPost. So team, any folks on the call, any questions, anything? Is anyone stuck somewhere until this step? Please do let us know in the chat. Okay. So team, folks, shall we start with the code? Or are you still downloading and uploading the files?
I think the upload is taking some time because I'm checking the size in terminal and it's taking time. It's 380 MB zip file, so it is taking some time. So I was thinking, why it's not unzipping? Because it's not properly uploaded yet. It's still, I can see the size is increasing. Slowly it's uploading.
Okay.
Like MB.
Right. So when you drag and drop on the top bottom pane, you will get like a blue color loading thing over here. So once it gets loaded, only then we have to unzip. So do not unzip halfway. It will take some time because it's I think 370, 380 MB. It will take about a minute or two for loading.
Yeah, I think it will take around 4-5 minutes because right now I have 61 MB loaded. So getting to 380 MB is taking some time indeed, yes. It looks like it's loaded because the zip file shows in my CS Hub folder, but the fact is it's still loading. When I try to unzip it, it gives an error because it's not complete zip yet. So till you see 380 MB, it's not
there
fully
will be
loaded.
a blue color loading. There will be a blue color loading symbol on the top bottom. Unless and until it is completed, we cannot unzip it. Otherwise, it will throw error.
It doesn't show me any symbol like that, but
okay.
The last modified is seconds ago. That means it's still under works. Last modified.
Yeah, correct. So let's say, for example, I load this, right? So let me just show that. So if I just drag and drop some file, right? So I just click on upload. You see on the bottom uploading, and there will be a loading bar. So until this is completely blue and you don't see this uploading bar itself, it means that it is loaded completely.
Mm-hmm. Yeah, that is one indicator. The other indicator is last modified keeps saying seconds ago. So if you want to check the size, if full 380 MB is uploaded, you can open the terminal. You can show where is the terminal and check the size by doing ls minus lrt. You can launch the terminal. You can check the size of the zip file which has been loaded so far. Is it in your root folder? Yeah. Yeah, so it should, yeah, you can see that 380 MB in the second last line. So that much we have to see. To check, that command is ls minus ltr in the relevant folder of your terminal. Those who have just joined, please download this code and upload in CellStrat Hub platform, please. It's a zip file.
Yeah, so I just copied another zip file. As you see, it's still loading at the bottom here. And the moment I do LSI LTR again, you see this, it is again increasing, right? So it's still not uploaded yet. So that's what it means. Okay. Meanwhile, um, any questions? Anyone on the call? Any questions so far? I mean, you're able to reach till this state. So once it is uploaded, as I said before.
It's taking 5 minutes for me. I'm still at 267 MB.
Oh, okay.
Maybe my network speed also matters, but I have high speed Wi-Fi.
Yeah, network speed also matters because I just copied this 7 minutes ago and it was a bit faster.
Mm-hmm.
Probably switch to the 5G thing rather than 2.4G of your Wi-Fi. Maybe it might be faster.
Mm-hmm.
Okay, so meanwhile everyone uploads and all, I'll just at least tell you what all this folder contains, right? So uh, once you load this .zip file, you have to right click, extract archive. So you will get a folder called as open post. Okay, it's basic, archival only. So inside that you will find a couple of, so two folders you will find. The first folder called as posts. So what that contains is you will get two different post estimation model. One is on the COCO data set and another one is on the multi-person image data set. And within that you will have the models. Okay, so these are your model files. Okay, and under your post API. So, I mean, so this demo has two different parts. Okay, one is we are just going to run a notebook and using the open post method and see how we can, detect the skeletal images of a human body, right? So that is one. And then we are going to develop this, create an API for this, right? In our CellStrat Hub and pass that image over an API and see how it detects from the API. So there are two different things. So whatever post API folder that I've provided here, it is almost the same code, but it has got its own structure and things like that. But I will come to that while we do the demo. But this folder contains your API codes, right? And then you have two simple images, and this is the, so there are two notebooks, open post underscore demo. So that is what we are going to run initially. And there is one more notebook which is open post underscore API. So that is what we are going to use for our deploying API model. Okay. So folks, shall we start with the open post demo to begin with? I hope at least majority of them have downloaded the zip and copied it into the hub. And meanwhile, I'll just take a pause for any questions, any issues, any challenges that you see till now. Okay, I would take that as a no. All right, so we're gonna start with demo. So once you are ready, you can open it. I'll just quickly cover just this demo, and while moving to API, I will pause and stop and uh, wait till you guys complete, right? Because API is little important. So so today's demo would be the open pose, right? So you will have open pose underscore demo notebook. What you need to do is just open it, and here so here on the right hand side corner you can set your kernel. So here in this demo I'm not using any of the PyTorch or TensorFlow code. I'm just directly reading the existing model and going to use it as a inference, right? So we don't need much there. We're just using the model's API and directly giving the output. Okay, so we can simply go ahead and use Python 3. That's more than sufficient. Okay, because I'm not going to train or test or do anything on that model. So this is just an inference. So here to begin with, we are importing all the libraries. So let me just run that. So we are importing all the libraries. The second one here, we are specifying the model. So as I said before, there is a folder called posts. So within that post folder, there are two different models. One is on the Coco and another is MPI, which is a multi-pose detection, okay, inference basically. And each one has, I mean, you can use any model, right? I mean, it's up to you. But here you have two models. So here, what we are giving is we are just setting up a mode, right? So whether we are going to use an MPI or whether you are going to use a Coco. So we are just directly explicitly defining it, and then we are storing all the proto files over here, okay, and the weights over here. So these weights are, you can see these weights here, right? So if you just go to this folder, this is your weight here, okay. So we're just using that. So we're just defining whether we have to use for which mode. So you can change your modes, right? If you don't want MPI, you can use Coco. Just change it to Coco over here, okay. And then we are just loading an particular image now. Okay, so I've just put two images here. One is multiple and one is single. So using multiple, we will just try to see how it gives you a heat map around the respective humans, and then we will go to a single pose estimation, right? So here in this code, I'm just loading the image, which is multiple.jpg, okay, and then I'm gonna pass that into the network. Okay, so while passing to the network, what we are doing is we are using the same weights file and proto files which I have already copied here. So just run it. So we are loading it through the, we are loading the network and we are passing the image through that. And then what we are doing is we are trying to see the probability map. Okay, so let me just open the image once for your clarity. Okay, so this is your image. Okay, and then what we are going to do is we are going to so basically we are, okay, here you go. Yeah, we are reading the image. Okay, we are loading the network, and then we are passing it to the network, and then what you're going to do is use the probability. So we are just using a plot IM show to just plot the output of the key points, right? So here in this example for multiple person, so we are just plotting the key points. So let's, as I told you before, right? You have an option to specifically point out your shoulders, your head, your maybe your knee, anything, right? So here we are just using heat map sort of a thing to show your shoulder. And then what we are going to do is we are just going to use an affinity map, right? So, and okay, yeah, there you go. So this is your affinity map. Okay, so basically you're trying to show where that image the is and where your shoulder is. Okay, so this is multi-person. Now how do you actually do the skeletal part of your poses, right? So here again the same code only, I'm not changing much. Same, I'm inputting an image, passing it through the loading the network, The network is already loaded at the top, so I'm not again loading the network, but I'm just passing the new input to the network, right? The new image to the network, right? Now, this is the code which is used to detect the key points. So from here till here, okay? So here what we are doing is we are using OpenCV, okay? So using OpenCV, we are running a for loop. In that, we are providing what are the key points to be detected for a particular skeletal image, right? Where did I run it? Sorry, I think okay, 1 second. Let me run this. Okay, let me run this. Okay, so here, from here to here, right? What we are doing is we are trying to identify the key points from your skeletal image, right? And then we are drawing that skeleton and showing the output. Okay, that is what we are trying to do. So for example, let me show this one, right? So this is your single image. So you have another image called single.jpg. So you see that there's a image of a person. So the first step, what it does is, so this part of the code, right? So this part of the code, what it does is, it will identify or track the key points. So you see here 0, 1, 2, 3, and so on and so forth, right? So this is what it will track. And then we are going to draw a skeletal structure using these key points, right? So that is what we are doing here in this part of the code. So we're using a for loop to identify those points and connect those points using the CV line. See, I mean, open CV line method, right? So you see this. So all these points are loaded. So you can get a good skeletal structure of the human body. So this is how we do a pose estimation. Now what you have seen is images, right? The same can be replicated using another method for videos as well, right? So as and when you have videos, it will kind of so I mean videos also does the same thing. When you have a video of, let's say, 1 minute, each frame is each video is converted into frames, and that image is what is getting utilized. Okay, and you have one of the most used ones is like there is something called media pipe. Okay, you can just Google it around. So it uses a real-time video post estimate. So have you all just run all this code? Are you able to get this output using this code? I just take a pause here for any questions.
I am still uploading because my earlier upload was corrupted, but I don't know about others.
Oh,
If I upload 2 times, you know what it does? It tries to upload it 2 times and corrupts the zip file.
oh yeah,
So
yeah, correct. So
you
you
have to
can't have
upload
the
it
same file
exactly
uploaded
once.
again and again. Yeah.
You have to upload it exactly once and just check the size 380 MB has come, and then don't upload again. Otherwise, it will corrupt zip file.
Yeah, so if you have a file which is getting uploaded, and if you again drag and drop the same file, right, then it will get corrupted, obviously. But if you have already uploaded a particular file and then you upload a file, it will ask you whether to overwrite or not, right? So if you see that option, that means to say that your existing file is already uploaded. I mean, that's another alternative you can look at. So folks on the call, any questions? I mean, are you able to, anyone has able to run this code?
Sir.
Yeah.
Is it like it will not depend on the t-shirt he or she is wearing? Like here, he is wearing a very quite skinny t-shirt, and that's why points are very easily detected.
No. It does not depend upon the t-shirt and all. It's not about the clothing, right? It's about the
Okay.
skeleton of your body, basically.
Okay.
Like if that is the case, right? You look at this one, right? So there are two key points here, right? I mean, unfortunately, he's wearing a sock, so I can't help. But basically, what I'm saying is, like, it doesn't matter about the clothing; it matters about the human skeletal system, basically, right? So your knee, your arms, your shoulder. So here you
Like
see like number
knee,
of.
arms, they are all edges now. Like what if the edges are not clearly visible, which is in like very bulky t-shirt?
Yeah. So no. T-shirts doesn't matter, as I told you, right? So your key points will still detect. So for example, if your T-shirt is, let's say, somewhere here, right? Maybe this point may slightly vary from here to here or something. Okay, but it will actually determine the size of your skeletal of the image and not exactly the T-shirt or something. Okay, but if the image resolution, for example, right, if it is too less and it is not able to detect, then of course it will not give you the accurate key point. That's why you have to go for another method. Like instead of open post, you might have to use another method, like for example, high resolution HRNet, right? So something like that. So for each input that you see, you have to determine or choose what method you want to use. So anyone on the call is able to at least just run all these codes, just do or another alternative is, once you get into this notebook, on the top left hand side, kernel, you can just do a restart kernel and run all cells. So what happens is entire notebook gets run and you will get this output. Are you able to at least get till here? Anyone on the call who's able to get till here?
However, how many were able to upload the zip file to their CS Hub workspace? Just send a thumbs up or okay if you are able to upload the zip file, 380 MB worth zip file. It's still uploading. It's still, for me also it's uploading. So who else was able to upload the zip file successfully to CS Hub? Just send an okay or yes in chat, please.
So I have uploaded 2 files here, right? You see this just on the call itself. So that's a strange behavior. Still loading. No. Okay.
And sir, hello.
Yeah, we can hear you.
Why not be the background images, like background edges will be detected? Like here na, where like edges, they are very sharp, but only the human will be detected here. Why is it not like the background edges will also be detected?
So, sorry. Can you repeat that? Background images.
Background edges, like.
You mean these things you're talking about?
Yeah. They will
No,
not.
no.
They will not count.
No. So here specifically we are doing only a human pose estimation. Okay. We are
Yeah, but
not
how will
going
we
to.
code like this? Like, how will we program to be specifically to be do in human only?
That's what I'm saying. So, see, there are two type of techniques, right? You can either detect an object, that is one, or you can detect a human pose. Predominantly, we use human pose, especially when you talk about pose estimation, right? Because objects doesn't have a pose. It's just a bounding box or bounding boundaries.
Okay.
Correct. So you can leverage any other technique for that, like even semantic segmentation or detection transformers also you can use for object detection. Here we are not focusing much on object detection. We are focusing more on human detection. So especially for human pose estimation, these people have, I mean, there are researchers who have come up with some techniques. So the model, see here we are, I'm not using I'm not training or testing a new model, right? I'm already leveraging the existing model that is already out there. So we have a COCO and an MPA model, which is already tried and tested by some researchers, right? And for example, I have given a note here. See, this COCO model has 18 points, and same way MPI model has 15 points as output. So this is already tried and tested using human images, and we are only doing the inference. Okay, so that is why here, if you see in the output, the one before output, right? You see here, it clearly indicates 0, 1, 2, 3, 4 till up to I think some 14, sorry, 17 or something, right? No, 11, 14, right? So 0 to 14, which is again 15 points, right? So here we are using MPI model. Look at this one, MPI. MPI has 15 points, right? So it will start from 0 to 14 basically.
Okay, sir.
Okay.
So I am running it now. I was able to upload and unzip it also. Does it take a long time to run, or it runs pretty fast?
It runs pretty fast. This is just an inference. I just did it in like few seconds. So
Okay.
I just ran this now again. So it just ran in few seconds. Maybe the initial reading the model, passing the model may take like maybe extra 10 seconds maybe, but yeah, less than a minute you can run this model.
Yeah, it's running for me. What is this 4 points, the stars in the first image? If you scroll up, there are like, yeah, this one. What are these?
So this is like, so for example, those are like your heat maps, right? So in this, what we are trying to do is we are trying to detect all the key points of your skeletal image, right? There we are trying to detect only a certain portion of it. Like for example, let's say a shoulder, or let's say maybe if you want to do a head or something, right? So here in this image, we are only focusing on the heat map and trying to see where your key points are there. Specific key point, basically. That's what it means. Here, what we are trying to do is get all the key points of the images of the particular person. And then you draw a skeletal around it. That's the only difference. So we can also do videos and all those things. But again, since most of them are on, folks, within CellStrat, we have different tiers. Okay. So one second, let me just show that. So you have different tiers. Okay. Some of the models, so like whatever model that I'm showing here, it will work on the free tier. But if you're going with, let's say, a video or let's say some of the advanced models, right? Most of them, it will not work on free tier. It will work on, let's say, alpha or beta or something, right? So that is also very important. So whatever I have shared today in today's session is a very lightweight, technique used. But of course, there are many. Sorry, somebody was about to ask a question.
Sir, I want to ask a general note. Like, if a group of researchers have, like, we are using here CNN, then we have to, like, it will have some filter also. Like, if some says some research group has discovered some, like, find some filters appropriate for the human poses, then we don't have to found. Like, we can use that only.
Yeah, correct.
Okay.
So see, you can do see again when you train a particular model, right? You need to have a lot of resources, right? And you need to use GPU and all to kind of train the model, and you need to have n number of images, high resolution images. Now that is typically not possible for us to kind of train a model and bring it here, right? Here we are just doing the inference for now, and researchers have already trained a particular model on some 10,000 20,000 plus images and some videos, etc.
Yeah.
Okay, you can go ahead and train a model yourself. So there is a Facebook model. Sorry, not Facebook. What is that called? 1 second. Yeah. Okay, it's called as Media Pipe. You can try that also. Yeah. Okay, Media Pipe. I think Google. Yeah, it's by Google. Okay. This is a new one. Basically, you can also see this. It does a real-time, media processing. Where is that? Okay, yeah, there you go. So there is this, yeah, okay, Media Pipe. Okay, so you can leverage this for real-time detection also. Like, let's say if you have a webcam, right? You enable it and write some few pieces of code for doing a real-time face detection. Okay, and it is already a trained model, by the way, right? Again, you are not going to sit and train a model here. You are going to leverage the API from this model, which is already developed, and then you're trying to incorporate that API to read your webcam, detect your face in real time, and then give you this bounding boxes. Okay, so you can see some examples over here. See, you look at this. I mean, again, see, bounding boxes and all those things are like face and all. But since we are focusing on pose, you have pose also, right? So media pipe, that's what. You see this? The last two examples. Okay.
Yes.
Okay. All right. So if at least a couple of, I mean, I hope everyone are able to reach till here. So can we move on to API? So let's try to see, how to
Yeah,
build an API.
let's do a survey. So how many were able to run the demo notebook? Please send a yes in chat. I was able to run it. Okay, Bhavya, yes. Who else? Please send a yes in chat if you are able to run the demo notebook. Because the next step is deploying of the model as an API. That's what Ranjith will show now. Anybody else was able to run the demo notebook? Yes or no? So Jay Ganesh, what issue are you facing? Okay, still uploading. Okay, fine. Okay, I guess Ranjith, you can show the API. Not many have been able to run it so far. I think the upload took a lot of time. The model run was very fast indeed, and it ran seamlessly. The upload takes some 5 to 9 minutes, I think, based
Okay.
on the
Okay.
Wi-Fi speed folks have.
Or maybe folks just try to log out, log in, and then try to upload. Sometimes it might be a little faster at least, right? I mean, again, it depends upon your Wi-Fi speed, but still. So, okay, fine. So let me go to the, how to deploy this as an API. Okay. So so I have also given a notebook called openpose_API. Okay, and there is already an API folder which I have created. So for those who are about to run that, right, you can probably leverage that, but let me run it in real time and show you, right? So the first and the foremost step, so I know you see all these things, right? So I'll probably go through that in detail. So so just be aware of what needs to be done here. There is a whole bunch of so let me go to that one, right? 1 second. So in your landing page or a hub page, there is something called deploy model. Okay, just click on that. Okay, so here if you see at the bottom, so I was just trying out few APIs, like for example open pose and then pose API. I was just trying it out, right? So that's what you, so once you have already deployed as an API, you will get something like this. Okay, so let me anyway run and show you how. So since I've already created this, I'm just gonna change the name, right? So let me say pose v1. Okay, so I'm not going to use the same thing. I'm going to use another one. So hub init pose v1. So first step I'm going to do is initialize the hub. So I'm just clicking on this. Okay, it says project initialization completed. Okay, now on the left hand side on the top there is a refresh button. Just refresh this. The moment you refresh, there is a folder that is created. Okay, pose v1. So here also I'm giving my API name as pose v1, right? So same way you will have a folder called as pose v1. So I'm just double click. So once you double click, by default there will be two folders and two files that are generated. You don't need to worry anything about these things. Okay, let it be as is and just follow the next steps. Okay, so what is important for us is the first two. Okay, the first one is a folder called as model. It will be empty. This is where we are going to place all the model files. Okay, that is very important. So let me just repeat it once again. The first step is you have to initialize your API, which means hub init post v1. Once you do that and go do a refresh, there will be a folder called as post v1 which is created. Once you go inside that, you will find 4 different files. The first 2 are folders. In the first, there is something called as the model folder. It will be empty. This is where you have to store all your models files. Okay. So if you have any model files which has been already trained and tested, or if you're, let's say you're going to newly create a model, also whatever model file is there, you have to put it here. And then you have something called SRC. SRC is a folder. Under that, you forget about the last one. There are 2 files, right? So one is requirements.txt, another one is main.py. So these are the 2 things which we are going to edit. Okay. So let me first.
I mean, basically, we are creating a Docker package. There's a set of utilities like hub init, hub start, hub build, which is basically contributing to create a Docker, a deployment package. Docker is a very popular, virtual container technique to deploy, AI model as an API. So we are basically contributing to creating a Docker package.
Right. Okay. So the next step, what I'm going to do is, so as I said before, in your master folder called as open post, which I have shared before, right? As I told you that there is a folder called post. Within that, you have Cocoa and API models. Okay. So what I'm going to do is either you can drag and drop it inside this. Okay. But then if you drag and drop it, you will not have this folder here. So if you are planning to run this code again, it will throw an error. Okay, so rather than that, instead of not moving it directly, all I'm going to do is just use a copy method, right? A simple Linux command. So I'm going to copy this from open post to post v1, right? Post v1. Okay, so I'm gonna copy. Oh, sorry. I'm gonna copy post. I'm gonna copy this folder post, okay, to this folder under this one, under model. Okay, that's what it means here. So let me just run this. There you go. You see this? So I'm just copying it. It's like a Control C, Control V, right? So, and when you go inside that, you will still find that. Okay. And your existing folder will still remain here. So you can directly go here and rerun this again for those who are not done, right? So otherwise what will happen is you have to again go inside this. So like, for example, here I have given a path, correct? You have to probably change the path if that is the case, if you have moved this post folder somewhere else. So that's the only thing, but nothing much. But so first thing is initialize it. You will get a folder. Then you just copy the existing model file, that is post here, to the model folder here. There's a model folder here. Okay. Then what I'm going to do is I'm going to do some changes, right? So let me do one thing. So where is that? Okay, yeah, source file. Okay. So go to main.py. Okay. So by default, you will get all this handy. So as we said, it is a Dockerized approach, right? So by default, when you run this hub initialization, you will by default get main.py, and this is where we have to copy paste the images. I mean the code basically. Okay, so just take a look at this here, right? So what I'm going to do is I'm going to copy these codes into main.py. Okay, that is what I'm going to do. So the first thing that I will do is import libraries. I will do it later because I'm not going to use all my libraries. The first thing that I will do is first is I need to specify the model to be used. Okay, so for that I'm just going to copy it here and I'm just going to paste it here. Okay, so I'm not doing any much changes. I'm just copying the model here. Okay, this statement. Okay, that I'm copying it here. Okay, so now you need to change the path, right? Because see here you have a folder, I mean you have something called as a model directly where it is getting the root folder, correct? Which is nothing but this one. Okay, but you have an additional post folder, and within that you have Coco and all everything, right? So what I'm going to do is I'm going to just use another simple function, no, not function, import statement. Okay, so let me do one thing. So I'm just going to use pathlib import path. Okay, and I'm just gonna do the path here. One second. Okay, and then I'm just going to give the model underscore dir and then this one. So this is basically nothing. All I'm doing is, see, if the model file is directly in this folder, let's say for example xyz.h5 or something, right? Then it's okay. You can directly use it. But I have some subfolders within for two different models, right? So I have to specify the exact path. So that is why I'm using this approach. Okay. So let me. So for example, in future, let's say for example, you're building some model, and then like if you're building some API, and then you have, let's say, 3 or 4 models to choose from, right? Then you can create like different folders of each model and put it there, and you can specifically use this model directory. Okay. So let me. So I'm just going to change the path. Okay. So till now, everyone is clear. So all I'm doing is just copy pasting the exact same code from here till here. Sorry, where is that? Yeah, in main.py. And all I'm going to do is just reference this particular path. Okay, that's all I'm doing here. Okay, next one is, let me go here. Okay, so here, okay, so the next step is we have to.
Can you scroll in main.py a bit above? What did you do?
So I'm just importing this library path.
From pathlib, you are importing path.
Path, yeah.
And then you appended that to the os.getEnv.
Correct. And then I'm directly using this variable here. So this variable will reference this particular model folder.
Okay.
From there, I'm just appending this path where the exact files are there, like model files are there.
All the 4 lines, huh?
Yeah, for all the 4 lines. I mean, if you have just one single model, you don't need to do all this. Since I have 2 different folders and 2 different files, right? Like you have a prototype file and a weights file. We are doing in that fashion. If you have, let's say, one single model, all you need to do is just place it here and you don't need to do all this. If you have more models, let's say you create an API for 4 or 5 different models, you may want to put that in different folders, and so that it will be very neat, right? I mean, that's how it is. And then use an if condition to choose that model, basically. That's the only difference. Okay. So next step, what I'm going to do is loading the image, right? So, okay, let me directly load this one first. 1 second. Okay, I'm gonna, so we'll use single person for now. Okay, so let's copy this. And okay, so this is where the main code will start, right? So I'm just doing a code. So, okay, so just go here, right? So here, what we are trying to do is, so here, what we have done, we have loaded an image, doing a frame copy and setting the width and height, right? So all I'm doing is just copying this, putting it in the inference handler, just pasting it here. Okay. Now, one important thing is you can't directly read an image here, because see what we are planning to do, we are planning to pass an image through the API, and then it has to do the post estimation and return an output, right? So this particular statement is incorrect. We cannot directly give an image, okay, or read an image here. Okay, instead we have to write 2 lines of code. Okay, so I'll just show that. Okay, so give me a moment. Okay, so these are the 2 lines of code. Okay, and you can leverage these 2 lines of code anywhere, right? So basically what happens is you are actually giving an image. That image is basically in the form of bytes. Okay, I mean the input or whatever is in the form of bytes. You need to actually read those bytes and convert it into an image. So that is what we are doing here. So for that there is a utility available called as Base64 To Image.
Can
Okay,
you send those 2 lines in
I
chat?
will send those 2 lines. Yeah. Okay, so instead of frame, you can give anything. It's just assigning some variable there. But what is important is these 2 lines, right? So basically, you are converting it, converting that byte image bytes, right? So when you input, it will be in the form of bytes. You are converting that to an image, and then just using a CV2 color to give all the colors, right? So these are the 2 lines which you need to put. What this 2 line indicates is the same. You're basically reading an image. Only thing is you're doing a conversion. You're reading an image will happen real time here, right? Or rather, I would say through an API here, correct? Here, all you're doing is converting it. So you are imagining that, okay, there is an input. You see this variable called as inputs. So when you run the output, like when you run the API, it will ask you for an input. You are giving an image. That image is stored in inputs. So that variable is inputs. That image, I mean, it will be in the form of bytes. So you basically are converting it to an image here. Okay, bytes are getting converted to images here, basically. That's what these 2 lines does. Now for these 2 lines to run, right, you need to import some libraries, right? So I'm gonna do, I'll also copy paste those 2 libraries. Okay, so give me a moment. Okay, so yeah. Okay, so this is that I was talking about, right? These 2 are the, I mean, utility to convert bytes to images. And then we are just utilizing import CV2 and num5 because initially in the code here, I mean, where is that? Yeah, in the code here, we have already used num5 and CV2. Time is not required, matplotlib is not required because I'm not using it anymore. We are simply going to run a simple single person API. Okay, that's why we are leveraging this. Okay, so I hope till here it is clear. Okay, now the next step, right? Now so basically here what we are trying to do is we have loading the image. That's the step here. Okay, so let me put it here, right? So load image. Okay, now once you load the image, you have to pass it to the network, right? Load the network and pass it, right? So here what I'm gonna do is I'm just gonna copy, one second. Yeah, just gonna copy. Okay, entire thing I'll copy. Okay, so just make sure that you select this and press a tab so that it is well within this inference handler function. Okay, just be very careful.
Which part of code you brought? Can you go back to the demo file?
Yeah, so I just bought the loading network and passing the image through network.
Load the network.
Oh, sorry. I think one second. I was using this, right? Yeah. Okay. Sorry. This one. I have to copy this one. My mistake. Okay.
Pass it through the network.
Yeah. I mean, more or less, both the things use the same, right? So whatever I copy pasted from the previous one, this is also more or less the same only. You see CV2 DNN blob file, and this is also the same thing only. Only thing is, so this is okay. Wait 1 second. Let me probably do this one, right? 1 second. I'm just putting the. Where is that? Okay. Okay. Now there you go. Now this will make sense. Okay. So basically, I'm loading the image. Okay. Then I'm loading the network, and then I'm passing the image through the network. Okay. Now here it's not image one, it is frame, because here I'm loading it into a frame, right? So I just change this here. Okay. And also another thing is when we are reading this, or sorry, loading this network, okay, what happens is we are loading these two files, right? So we have to load it in a string format. Okay, str we have to do. Otherwise, what it will happen is it will throw an error. That's the only change I'm gonna do. Nothing much. Okay. Yeah. Okay.
Maybe you can just copy this code from inside this inference handler, put it in chat, so I can copy it as it is.
Okay, fine. I'll do that. Yeah, I'll do that.
Inside inference handler, whatever you are putting, just send it to me, please, or inside in the chat.
Sure. So
See, when Bhavesh has presented these APIs workshops, we didn't have to copy so many demo code here.
No, I've already given the existing main.py file as is. Okay. But I'm just showing you where all the changes has to be done and what all we need to do.
Okay. Yeah, there is a lot of main PY changes. Bhavesh is on the call, I think. I didn't see so many changes before in main PY in other APIs. But anyway, please continue.
Okay. So, okay, let me do one thing. I'll just copy paste this, right? Because otherwise it will take a lot of time for you folks. So let me do
You're
that.
sending the entire file, entire inference function.
Yeah. The main.py.
Oh, you're sending the whole file. Okay.
Okay, it doesn't go through this, is it? Okay. No, it doesn't
Just
go in
send
the
the
chat. So
inference function. Send the inference function.
okay, fine. Okay, there is a break in this also. I think in the chat only a certain set of, there's a
You can
limitation in the number of characters.
download this file, upload to your Google Drive, and send it to us through Google Drive.
So okay, so let me do that, right? So one second. So there is already a folder which I've shared as part of the zip. There is something called Pose API. Okay, so just go inside that and go into SRC. I would have already created that main.py and requirements.txt.
Okay, so we can copy those two, huh?
You can directly copy those two and place it there rather.
Got it.
Okay, in the interest of time, you can do that. So let me also try to do the same thing, right? So basically what we are trying to do is we are just copying the same code what is there, which we did in the Jupyter notebook. Okay, we are reading the image, we are loading the network, passing the image through the network, and then we are getting the points, the key points, right? The skeleton key points, and then drawing the skeleton. Finally, what we are doing is instead of directly returning the output, we are just storing that as an image in a temporary folder. That's what it is. That's what this last point means. So folks on the call, to make this easier, there is a folder called Post API. Just go inside that. Okay. And go to SRC, go to main.py. You can directly copy this and paste it there, or just go inside and paste the same code into your own, main.py function. Okay. So let me save this. So I hope you're able to copy everything. Now, one last bit is I think the requirement.txt also needs to be edited. Okay, here it is, nothing is there, right? So I just say OpenCV-Python because I've used OpenCV for this and just save it. So just open requirements.txt and just give this OpenCV-Python. Okay. I think rest of the packages are there. Yeah. Okay. So I hope everyone has completed till here.
Yeah, I copied those two files from Pose API to my open Pose model.
Okay, perfect. Yeah, after that you can you can just do a cd space wherever that file is. So here in this case I'm doing this thing is folder is post v1, right? So just go to that folder and then I directly deploy it.
Mm-hmm.
Okay, so let me just deploy it. So while deploying, if at all, let's say for example, you have not updated any libraries in the requirement.txt, there would be sort of an error here. You can go and then add those.
Yeah, I'm running hub build.
Yeah, it will take a couple of seconds here. Building image. Okay.
So we are doing build and deploy in one line, huh?
Yeah.
Okay. So it is deploying for me now.
Yeah, it will take some time. So once it is done,
Model deployment in progress. Step 3 of 3 of deploy.
yeah.
Okay, so API reference point has been created.
Okay, so it has been created, right?
Yeah.
So, okay, so in the next line, under API key, so you need to change the API key. So what we need to do is just go here to deploy models. Okay, so in the CellStrat Hub on the landing page, so just click on deploy models. So on the first option, you can see there is something called as an API key, right? So you just click on this, copy this, and paste it here. So, I mean, each person will have their own API key. So just paste it here. And then on your endpoint, once you get the previous line, right? So you will have something called your inference API endpoint is so and so, right? So you can just copy that and paste it here. Yeah. So API key, you have to go to deploy models and you will find something called as an API key over here, key ID API key, click reveal, copy that directly and then paste it here. Okay. You will have your own API key, placed it there because if you use some other API key, you cannot even view it in your this thing. I mean, it will not be visible in yours here. So like for example, look at this one. I have three models, API models deployed, open post, post API and post v1. This is something that I've just created right now. Okay. So here, give your API key, give your endpoint and just click on run. Okay. And then basically here we are giving the request now. So let's run that and see the response. Oh, sorry, not response, request output. And 1 second. Ubuntu open post single. Okay. So folks, you are able to get this API key and endpoint. So API key, you have to go to the hub and find it from there. Your endpoint, you will find it over here. Like once the previous line is executed, you will find a inference API endpoint. You just copy that and paste it here in this part. That's it, right? And okay, so till here I have completed, and then now model is loaded in memory. So I just open an image So here we have single.jpg. So I'm just giving the entire path for it and then converting into this thing and sending the post request. So let us see what happened.
Yeah, I was able to get the pose estimation on that person image. I'll try with a different image now. Can I do multiple .jpg or image also?
Yeah, you can do, but this code is specifically for single pose, whatever I've copied. Okay, so we have to modify the code little more for multi-person. For now, whatever this API that is created, right, it is only for a single person.
Okay.
So maybe you can just use some, Google Images something, right? So here again we are just converting using pill image and showing that output here. Same output you will get here. Maybe you can just download some Google image or use wget to download that image and then.
You mean one person image?
Yeah, one person image, correct. I mean, multiple person image also will come, but your skeleton will be messy. Because this code is not meant for multiple person. This particular API code is meant for only single person. Like
Yeah,
that you can change
trying
your.
to connect the pose of all the 4 people if I use multiple.
Yeah, correct. Because it will try to see that if it's like it'll assume that it is a one person, right? The 4 people are like one person together,
Yes,
and
yes.
it is trying to do that.
Mm-hmm.
It's like it'll detect like you have 4 hands, 5 legs, and all. So, any questions, folks, on the call? Any questions? Are you facing any issues, or are you able to at least directly run this on your hub? Any questions posted? No. So more tutorials, if you, when I say tutorials, I mean like if you want to look at how to deploy this API for any of your, models, right? So there is an option here called Learn How to Deploy. So once you click on it, it will give you clear instructions around how to deploy a particular model as an API, right? So basically, I just use the same code from here. So forget about this. So we start with initialize. So we have initialize. So here they are using a sentiment analysis as example. You get a same structure that you saw earlier, right? And then you copy your model files to a model folder, add your own code to main.py, and then you do the inference handling part within that. Okay, the same steps. Okay, and then you update your requirements.txt file, and then you build and deploy. So I've just used same thing over here, and then finally you're testing your API, the same thing, right? So you can either use an API key, username, API name, or you can directly give that path and then request. That is what you see here. And then finally your sample input will be sent as a post request and then your output, right? So I just simply ran through it, but more or less it is using the same thing. Only the last part where we are finding out an inference, it might change slightly because what you see there is more of around your text output, right? Here it's more of an image output. So please remember that you need to convert it and then get the output in the form of images here. Okay, with that I think we are done with this session. So I'll just take a pause if any questions or any other challenges that you see in running the code before I hand it over?
Yeah, I'm trying with the new images from internet with one person. Is showing nicely. So let me share my screen. I'll show you a particular output I got. Can I share my screen?
Yeah, I'll stop. Yeah.
So check this image. So this is one of them, right? So yeah, I guess the bodily motion is not that much. But let me show you another image I tried. I have loaded 4 kinds of persons. So this one shows nicely a runner, right? And then let me try some Indian sports folks. So this is Virat Kohli. So you can see it's doing pose key point check, right? And let me try a badminton champ.
And one more thing is, like, in case if let's say your image is, let's say, cropped somewhere in the edges or something, right? It may not be able to detect that particular key point. So
Yeah.
you may not get the right output.
Yeah. So you can see a badminton player, right? So it is doing good job. Okay. So I just tried some random images. So interesting. So anybody else was able to do it till the API run? The API is a little complex process.
No, I guess I joined little bit late. So can I get the link of the recording so that after this meeting I will test and run it?
Yes, yes, it will be provided in our YouTube channel.
Okay.
So the API process is slightly intricate, yes. So you have to follow it precisely to get it working.
So almost 60-70% of your existing code in your Jupyter notebook will remain same, but then to suit this as a particular model in API, you have to use some extra additional codes. Okay, this is for any of the models that you want to deploy, right? Almost 60-70% will be same. Maybe like 20-30% you have to write few lines of codes to convert it. But I think if you're leveraging images and all, I think I've already given the base conversion code, so you can leverage that even if it is an what do you call it, video, right? Basically you will convert the video into different frames of images and then you will do the output. So that's how the video pose estimation works. It will again convert it into chunks of images and then automatically it will detect in real time. Probably that way I will try working it out, and maybe in the next session I can show that.
And one more question, can we test this API via Postman, like the URL that we are hitting?
You can try it. I'm sure. I mean, it's a full JSON compliant API, so you can try it for sure.
Okay.
We are also working on a UI stack of our own, where you'll be able to create, UI easily for your APIs. So that is also under works. So you can have a full stack with a UI, a user interface, calling the API. So that is under works right now. Okay, Ranjith. So are we good?
Yeah, Vivek.
Okay, so anybody else was able to see the API? Jay Ganesh or anybody? Run. Okay, so I guess you can check the recording and try it at your end. Okay, so do check the recording on our YouTube channel and then try it in your offline time. So thanks a lot, Ranjith. A nice session and pretty intricate stuff indeed. Did you cover the PPT as such, or there was something left in PPT?
No, PPT is over. That is just a quick introduction of POS and the methods.
Right.
I not covered in depth on any algorithms because it typically uses CNN, and it's just an additional layer, and some of the additional techniques are getting utilized. So each method will be different from another method. So we can directly use, I mean, there are lots of APIs available, I mean, the models or methods. So we can leverage that and do all sorts of inference. One of the most popular one is OpenPOS, which we showed today. But we can also use media pipe, wherein you can run it on your webcam and try to move your face and all, and get a real-time pose estimated.
Now, Ranjith, can you work on launching this as an API in our API marketplace?
So the images may not be a good option, Vivek. I will try to run it on maybe like as I told you, the webcam image, right? So once I try that, probably I can see if I can connect to maybe an open API for let's say a surveillance or something, right? Maybe that will be a good use case as compared to just images.
No. I mean, Edge API can still be there as an enablement capability, right? For a single image also. And let the client developers, I mean, you never know. There will be some kind of clients which probably need a single image.
Okay.
But most likely multiple image is better than single image, right? So multiple image pose estimation. So video image estimation is one use case, and static image estimation is another use case. So you never know what. I mean, we can launch it as an API. I'm thinking in the public marketplace. Why not?
Sure, Vivek. Yeah, well, you can do that.
Yeah. So okay. So with that, we come to the end of this workshop. Thanks a lot, Ranjith. Very nice session. And our deployment was very interesting. At least I was able to deploy and run it, and others can try it in their personal time based on the YouTube recording. If you want to work with CellStrat or collaborate with us, do reach out to us. Thanks for joining today. Thanks a lot, Ranjith. Look forward to your next sessions. Okay.
Thank you, Vivek. Thank you, everyone. Have a good day.
Thank you all.